Our next chapter is rate measure. This chapter comes for 4 marks in your final exam. So our first question is, if particle is moving in a straight line so that after t seconds its distance is s in centimeters from a fixed point on a line is given by the equation f of t is equals to 8t plus t cube. Find the velocity at time t is equals to 2 seconds. Second question is the initial velocity, and the third is the acceleration at t is equals to 2 seconds. So here the given is the distance here s is equals to given s equals to f of t, which is equals to 8t plus t cube. Equation 1, differentiate it, so we'll get ds by dt, which is nothing but the velocity, the rate of change of displacement, is equals to, here 8 as a constant, t derivative will be 1 plus t cube derivative will be 3t square. So this will become 8 plus 3t square. Again differentiating it, rate of change of velocity is acceleration, so it will become dv by dt, which is equals to the acceleration a, which is equals to 8 is constant, constant derivative is 0 plus 3 into t square derivative will be 2t, which is equals to 3 to the 6t. Take it as equation 2 and this as equation 3. And the first question is to find the velocity at a time t is equal to 2 seconds. So we have to write the velocity equation, which is v equal to this. So v is equals to 8 plus 3t square at velocity at t is equals to 2 can be given as v is equals to 8 plus 3 into 2 square, which is equals to 8 plus 3 into 4, which is 12. V is equals to 8 plus 12 is equals to 20 centimeter per second. Now the second question was initial velocity. We know that initial velocity will be when time is equals to 0. So v is equals to 8 plus 3t square. Initial velocity at t is equals to 0. So this will become v is equals to 8 plus 3 t is 0 square, so it is v is equals to 8 centimeter per second. And the third question is to find the acceleration when the time is equals to 2t. So a equation will be a is equals to 6t, equation 3, 6t. So a is equals to time is equals to 2 seconds. So 6 into 2, acceleration is equals to 12 centimeter per second square. Next, the second question is the distance time formula for the motion of a particle along a straight line is given as s equals to t cube minus 9t square plus 24t minus 18. Find when and where the velocity is 0. Okay, so we have to differentiate this, so we'll get the velocity equation, right? So given s is equals to t cube minus 9t square plus 24t minus 18, differentiate it, so we'll get velocity is equals to rate of change of displacement, which is equals to 3 into t square minus 9 into 2t plus 24 into 1 minus 0. Velocity is equals to 3t square minus 9 to the 18t plus 24. Taking 3 common here, so we'll get v is equals to t square minus 6, 3 is 18 and 8 is 24. So now we have to keep velocity as 0. So substitute v is equals to 0 in the equation. We'll get 3 into t square minus 6t plus 8 is equals to 0. So it is t square minus 6t plus 8 is equals to 0. So this will become factorization. 4 2's are 8. So it will be t square minus 4t minus 2t plus 8 equal to 0. So taking t common, so it is t minus 4, and here also it is t minus 4 minus 2 will be the common factor of both. So we'll get here the two values of t minus 2 and t minus 4 equals to 0. So t is equals to plus 2, t is equals to plus 4, right? Now this is the time period when the velocity can be 0. That is t time is 2 seconds and 4 seconds. Okay. So the velocity is 0 after 2 and 4 seconds. So the case 1, time is equals to 2. So we should find the equation of it. So s is equals to t cube minus 9t square plus 24t minus 18. So now substitute t as 2. So it will be 2 cube minus 9 into 2 square plus 24 into 2 minus 18. So this will become s is equals to 2 cubes is 8 minus 9 fours is 36 plus 24 into 2 is 48 minus 18. So s is equals to, we'll get 56 minus 54 is equals to 2. Okay, now similarly solving for t is equals to 4, case 2. So we'll get case 2, t is equals to 4, s is equals to t cube minus 9t square plus 24t minus 18. S is equals to 4 cube minus 9 into 4 square plus 24 into 4 minus 18. So S is equals to 64 is 4 cubes minus 4 fours are 16. 16 into 9 is 144 plus 24 into 4 is 96 minus 18. So S is equals to 160 minus 162, which will be equal to minus 2. Therefore, the particle is at a distance of 2 units from starting point O on either side. Third question is, the point P is moving on the curve y is equals to 2x square. The x coordinate of P is increasing at the rate of 4 units per second. Find the rate at which the y coordinate is increasing when the point is at 2, 8. So here the given curve is solution. Given curve y is equals to 2x square. So here x coordinate is increasing, right, at the rate of 4 unit per second. So we can write it as dx by dt. Rate means always is with respect to the time period, okay? So which is equals to 4 units per second. Now differentiate this curve with respect to x, we'll get dy by dx is equals to 2 as constant, and x square derivative will be 2x into dx by dt with respect to the time. Okay, so it will be dy by dx equals to 2 into 2 is 4x into dx by dt value is given, which is nothing but 4, right? 4. So this will be 4 into 4 is 16x. Now we have to find the y coordinate. In this we have to find the y coordinate at 2, 8. So it is dy by dx at 2, 8 will be equal to 16x is equals to 16 into the value of x is 2. So it is into 2. So it is 32 units per second. Next question is, a stone is dropped into a quiet lake and ripples move in circles at a speed of 5 centimeter per second. At the instant when the radius of circular ripple is 8 centimeter, how fast is the area enclosed increases? So here we have to find the area of the ripples, right? So which is nothing but in the shape of a circle. So we have to find the area of a circle when the ripple is 8 centimeters and the radius is increasing at a distance of speed of 5 centimeter per second. So let us consider as, let r and capital A are radius and area of circle at time t. So given dr by dt is equals to the speed of the ripples, right, which is 5 centimeters per second, and the radius is given as 8 centimeters. We have to find the area increases, right? So give area of circle A is equals to pi r square. So it is dA by dt. Differentiate with respect to t on both sides. So it is pi is constant. R square derivative will be 2r into dr by dt. Now substitute the value of r and dr by dt in this equation. We'll get pi into 2 into r value is 8 into dr by dt is 5, which is equals to 80 pi by 80 pi centimeter square per second. Area unit is square, right? A container is in the shape of an inverted cone, has height 12 centimeter and radius 6 centimeter at the top. So there is a inverted cone here, okay, and its height is given, right? Its height is 12. So we can take the height like this. So this complete is 12 centimeters and the radius on the top is 6 centimeters. If it is filled with water at a rate of 12 centimeter cube per second, what is the rate of change in the height of the water level when the tank is filled up to 8 centimeters? Okay, so there is two levels of the water here, so we can consider another is somewhere here. Okay, so here we can take it as the triangle to form here B O and here C and this as D. Okay, so we know that the AC is the height of the cone, and similarly like this also we can take the radius as the CD as R. Okay, so let us consider here there is a water level is mentioned, so it is a capacity a container can hold. So here we have to use the formula for volume of a cone, okay, because it's a capacity contained. Let R H V R radius, height, volume of cone at time t. Let AC is equals to H and CD is equals to R. Given OB is equals to the 6 centimeters radius of the top and OA the height 12 centimeters and dV by dt is equals to 12 centimeter cube per second. Now we can get from the diagram like two triangles are formed which are similar, that is AOB and ACD, right? So from triangle AOB and triangle ACD, OB by CD, okay, the radius is OB by CD is equals to the height OA by CA. Substituting the values here, so we'll get 6 by r is equals to 12 by h. 6 ones and 6 twos are 12, so it will be cross multiplication, so it is 2r is equals to h. From here we'll get r is equals to h by 2. Now write the formula of volume of cone, which is equals to V equals to 1 by 3 pi r square h. Differentiate with respect to t on both sides. We get dv by dt is equals to 1 by 3 pi into r square. Derivative will be, first we will write the value of r, then we will differentiate it. Okay, so it will be h by 2 whole square into h. So this can be written as pi into h square into h is h cube by, here 2 squares are 4, 4 into 3 is 12. So we get dv by dt is equals to pi h cube by 12. Now differentiate, so it will be pi by 12 as constant. H cube derivative can be written as 3h square. So it will be 3 ones are 3, 3 fours are 12. So we'll get here as dv by dt is equals to pi by 4 into h square. Into here we have to write dh by dt. Similarly also dh by dt. Now substitute the value of dh by dt, which is given in the question as 8 centimeter. So we'll get dv by dt is equals to 12 centimeter cube per second. So we'll substitute here. So we'll get 12 is equals to pi by 4 h square into dh by dt. So this 4 is multiplied with 12. So we'll get 12 fours are 48 is equals to pi h square into dh by dt. Okay, shifting this term there. So we'll get dh by dt is equals to 48 by pi h square. In the question it is given as the level of water it as a at a height of 8 centimeters, right? So we'll get dh by dt is equals to 48 by pi into 8 into 8. So it is 8 ones are 8, 8 six are 48, 2 threes are 6, 2 fours are 8. So the answer will be 3 by 4 pi centimeter per second.